So you should have them.
It should have both. Okay, we just need to change the. Get us to get it.
I think I have the latest version.
But we have 2 sessions for him. One is template-driven connect for TCP, which is active, and then we have template-driven HTTP request proxy.
Yes.
And they have very similar front pages, so I just want to make sure that yeah, we have both sets of slides. So right now I have the template connect in the GitHub repo, but not in the template HTTP. Yeah, it could be I just didn't, download it.
I think that's because they came through Data Tracker.
Okay. I think they both came through Data Tracker. That's for TCP. That's the one that's adopted. Okay, good. And that's the other one. Good. We're fine. We're good. I just need to update the GitHub repo at some point. Who do we need? Who's the bunny? Yeah. The one you shoot.
The note taker?
Yeah.
Yeah, okay.
Ah, Andrew. The bunny.
You like notes?
Come and sit and take a luxurious seat at the table. Oh, wait, you don't have a computer with you. Huh? It's not going to be a long meeting.
It's Friday.
It's Friday. Everybody wants to go home.
Get some sunlight maybe before they go home.
Sure.
Certainly not in this room.
No, indeed. Well, the nice thing is we can see them as much as they can see us.
That's true.
Should we?
We're at time, yeah. Let's get started.
Go?
Okay. Hello, everyone. Welcome to the final session of Ietf 123 here in Madrid. Thank you for being here. And we're going to try to have a great, energetic session where we're not going to spend too much time and let people get back to what they need to do. But we do have a good agenda coming up, so we want to get through that. Are you controlling this?
I am right now, yes.
Okay. We do have a note taker. Thank you, Andrew. And here's the note well. I really hope you've seen this by this point in the week. These are the terms under which we participate in the IETF. Next slide, please. Okay, that was Wednesday. We're on Friday. So we do have one edit. We're not going to be covering Novari Search today, but we will be going through the rest of this agenda. So we'll be going through 3 of our currently active drafts on unencoded digest, secondary certs, and TCP Connect. And finally, we also have 2 new proposals that we'll be discussing. All right, any agenda bashing? Any questions? Very good. Okay. So let's get started. Do you want me to drive it? Sure. Okay, happy to.
So we're skipping Novari Search. That takes us to.
Yeah, so we are Lucas unencoded digests.
Lucas Pardue. We don't have Lucas. Yeah, there are people coming down the stairs.
We can
Build the anticipation.
I also need the Okay. Let's just swap out. Eric Grabati, are you online? Do we want to jump over to run through secondary certs quickly? Let's see, do we have him? No.
Wait, Lucas? Is that you back in the murk back there? Lucas. Hello. You have a draft.
Come on.
I know you're ready to go home. You can bring it up here. It's okay.
On the wrong day.
It's fine to waste a little time here because people are still filtering in. Do you want to try to? You want us to do the slides?
I'll do it. I'll do it.
We've got the clicker here.
I'm having trouble getting it, but it is here.
I thought I was second.
The first one is not happening.
Okay.
It's very quiet, very dark.
This is good.
Put your head down for a moment.
Apologies for the delay.
Are you not entertained? That's a clear no.
Sorry, the slides are being finicky. Do you want to just start introducing while we go?
I can't remember what I was going to talk about.
Here we go.
That's
There
the
we go.
problem.
Hold
I need prompt. Okay. So I'm Lucas. I'm presenting about the unencoded digest draft that was adopted between the last Ietf meeting and this one. Some of these slides are copied from last time, but again, a recap because this stuff always enters people's ears and then goes out as the other one. So this is just a request for a thing at example.com with an accept encoding of gzip. So the response could include a response that is gzipped or not. Next slide. In this case, it is, because it has a content encoding gzip. And we have the wrapper digest, the representation digest, which is the hash of the message with the gzip encoding applied. The unencoded digest, that was the new draft that we've adopted, is below that and has a different value because it's the digest of the response message content in this case, even though it's really about representations. But in this specific case, it's about the content that was sent, but without the gzip encoding applied. So say you were going to verify that unencoded digest on the client that's just got it delivered from the message, they would need to remove encoding to be able to get the right bytes to calculate the digest of to confirm that this hash matches. Next slide. And I kind of alluded to differences between content and representation and stuff. It's Friday afternoon at the end of the Ietf is not the right time to talk about this. But what is the difference between these slides? I changed some of the words. We can head that resource. So we're not going to ever have any content bytes in the response. But we maintain the representation digest and in unencoded digest. We maintain them that are modified. So that's the power of what this feature does, in that you can communicate digest for things without having to include the actual content of them, which sounds weird, but it's really useful if you've already, say, downloaded that content, maybe over a series of range requests that you stitch back together that you want to verify the whole thing in one go, but you don't know, you forgot what the digest was, say. It was a point in time in the past. So you know where it was living, you can head the server and do this verification. Next slide. So that's kind of what the draft allows for doing. Since the last time, since adoption even, we've made one change about parameters. So this was my co-author, Mike West, writing tests for an implementation of an encoded digest specific to signed or signature-based integrity, this W3C thing, which is the primary use case here, writing tests and realized that we didn't accommodate for parameters. There is maybe a use case where you would like to use parameters on the unencoded digest and want unencoded digest fields, and we didn't say anything about those parameters. So the change was just to add text to say that each value, the unencoded digest is a dictionary, so each value in there can have 0 or more parameters, which is what the structured fields allows for. But that at this point in time, we don't have any use of them, so ignore them, and that there could be ones in the future. Pretty simple. And this is an example of that, kind of using the previous thing, but without the wrapper digest, that whatever that extension might be, there's a parameter on it. And if you don't know what that parameter is, you just ignore it. Next slide. The realization quickly then was we forgot to do this on the old headers, which is annoying. So what to do? we discussed some options. Sorry? Someone in the room suggests we could do a revision of it yet again. If we go on to the next slide, we discussed some of these in a pull request, so I wanted to surface up the discussion. And yeah, that's annoying. We could do nothing more and leave the old drafts saying nothing and the new one saying something. The bad thing with that is that all of these fields are around the same topic of digest and they're complementary. We could have done the identity digest back in the day with them all as one thing. It seems very odd to not say something, even if that was the implicit intent, because realistically, if you're going to parameterize the unencoded digest some way, you probably want that to apply to the other digest too, because they're not a substitute for each other. They could be used independently and they can be mutually exclusive, but actually using all three is weird, but can provide a property that you might like. So I'd hate for there to be some weird interop issue because someone interpreted the absence of text in the old ones to mean more than it did. Marius suggested we could maybe just file an erratum on the old draft. To me, my experience of erratums is this isn't just you said some words wrong here, or like this must should have been a should, and this is why. This is, in the previous slide, I had some links to text. It'd be adding a paragraph to each definition of the thing, which is way beyond what erratum. This isn't the right text, sorry, I just remembered. But yeah, the document, the new one, unencoded digest, could formally update the old drafts, kind of do a patch to say, oh, it didn't say this, but this bit applies. And if you're, if you remember when you're looking at RFC 9530 to click, oh, updated by link, and manage to keep all the context in your head, you would do the right thing. That might work. We could do a bis. If you're going to do a bis, is that the case where actually you just combined these two pieces of work and just did the bis and put the identity digest back in there, which we could have done at the start, but we decided not to, but whatever, I could live with that. And then the other question I've got is, if you look at the text, it's a paragraph about the parameters. It's then defined everywhere. Each header definition has the same text. It's very duplicative. Could we just find a way to ameliorate those differences and say at once that all of the fields defined by this thing all have the same approach to parameters? That's all I've got.
All right, we have a queue with Mark.
I'm not going to bother going over there, but this is just me. This is me as structured fields author. The intent has always been with structured fields that the default is that unrecognized parameters are ignored. And there's language, I need to look up the old one, but in the new one, there's language that makes that pretty explicit. I think we had language like that in the old one too. Mm-hmm. And so I think a reasonable implementer, if they cared enough to think about this, which is always a good question, would default to ignoring. And because the spec, at least the newer spec, says basically if you want to deviate from that, we discourage that. And so the presumption there is if you do want to deviate that as a specification, you need to do some work and explicitly say so.
Mhm.
And if you don't say anything about that, first of all, if you do say something about it, it's probably a bad idea. But if you don't say anything about that, the only reasonable default is to ignore parameters.
Okay.
Now, could we have spelled that out better? Sure.
Okay.
But I don't, opening up documents and updating them and so forth seems excessive to me.
Okay. Should just in response to that then, should we take the text out that we've just added?
It does not hurt to be explicit.
Okay. Oh, that's good clarification.
So you are saying option 1.
Yeah.
Do nothing more.
I think that would be fine. I
Thank
think
you.
if you ever open the, and I think frankly, an erratum with a hold for document update would probably be adequate. So maybe option 2, in that, if someone cares deeply about this, you can point to the erratum and that it's captured that if those documents ever do get updated by older Lucas, one would assume, then, we remember that.
I could live with that as well. Okay. Marius?
Marius Kleider. I would like to voice my support for option 3, because in the HTTP API working group, we have a document about problem types for digest fields. And currently they are phrased around content digest and representation digest, because that's what's already an RFC. But it only uses a definition from 9530. So technically, it would also cover the unencoded digest if the new draft basically updates the definition from 9530 about what integrity fields and integrity preference fields are. So then, yeah.
Okay.
You
Yeah.
have like a new,
It still covers that.
then like the definition is now updated to include unencoded digest, and whatever references that definition also covers the new unencoded digest. I think that would be kind of handy for the process.
Yeah, you raised this issue, and I didn't understand what you've just said from the issue. If to replay my understanding, we in RFC 9530 we define these terms, digest fields, and integrity fields and integrity preference fields, I think, and that we could update the definition of those fields to include this new thing as an updates, right? The integrity digest is now also part of that formal term, and that the thing about the parameters implies to those fields that are included in that term. That is an option. I don't know if anyone likes it, but we could.
Yeah, that's phrased in a better way, yes.
Martin.
So RFC 6919 doesn't specify the are discouraged from, which is the language that 9651 uses for these things. But I think it's pretty clear. So I think that I tend to go with the erratum thing. I would also like to see an erratum filed on 9651. So, but it's not the right thing for an erratum, really, is it?
So I'd have to go back, but I believe that was a result of the consensus process, and that was the
consensus.
balance that we reached at the time.
Yeah.
I think as long as it's mine for camera.
There's a Medico person screaming into the night right now. Did I
Okay.
pronounce that correctly?
Can we just go to the last slide, because I've got to say, because as alluded to, Mike has been working on some implementation work for his stuff, for the signatures-based thing. Is anyone interested in doing some implementation work? It'd be nice, get in touch. Otherwise, I think in terms of any planned work on the draft, we're done. Obviously, things could come up, but there's no anticipated new features or anything that we're holding for. So maybe we sit on it for a bit, but otherwise it's potentially ready. Review is always welcome, but it's just a lift and shift of all of the same text we had in the old draft to the new one.
Is it worth talking about the naming of the field, or do you want to leave that firmly closed?
we've got time for a bike shed. Why not?
There was a bike shed there.
Yeah, do we want to run it now?
I was thinking more about noting that other names were considered and then moving on, rather than reopening the bike shed.
Okay. There were other names suggested. We had that discussion pre-adoption. We came up with this name, and the adoption call went out, and no one,
Yeah. No one pushed back.
no one pushed back. It's an ugly name, but they're all bad. The issue is, I'm not averse to a rename, but for the work that Mike is doing, it is being used in other specifications too, and there'd be knock-on ramifications to renaming, but
Yeah.
they're unfortunate. But if that's what people would really strongly advocate for,
No, just giving people context. That's all.
okay.
Yeah. I do not detect a rising up of the masses to do that. Not on a Friday afternoon.
I'd say that
If anyone cares, please speak up. Otherwise, we're going to assume that we are generally fine with this, and we'll confirm that in last call when we do.
the reason we landed on that name is because when you're actually talking about the semantic kind of context of this stuff, you have to call it the unencoded digest anyway. That's what I was finding. So just name the field the same thing as the object.
Yeah, the only other possible name would, I think, be like identity digest, but that's very HTTP insider baseball.
Yes, and it would.
Yeah.
I'm gonna go. Thank you all.
Thank you.
Bye.
Next.
Okay, next up, we're going to do secondary certs, I believe. Eric, I see you online now. Do you want to share slides from your end? You can request permission, and I can grant it, which would be great because our Wi-Fi here is still a little sketchy.
Yeah, it sounds good to me.
Good morning, by the way.
And good morning.
You say buenos tardes.
Buenas tardes.
All right. Hello, folks. Gonna have a quick chat here about secondary certs. So the current status, there's still this one major item to discuss, which we will discuss more, being the whole sending large secondary certs over HTTP2. And then, of course, there are also continued editorial improvements, but the main issue really to discuss is going to be this one regarding the large certificates over H2. So on this issue, for reminder and context, the thing that has kind of come up here is that when we're sending secondary certs on the control stream, and we're essentially saying that, that the entire certificate needs to be completed on the control stream over H2, that might result in a considerable amount of head of line blocking, and also just not actually fitting within a single frame for HTTP2. So we do need to find a way around it. The discussion last meeting was centered around considering a new stream type to handle this. And, this kind of ends up working sort of similar to server push, essentially. And so regarding server push, there is an idea here where we could have like a server certificate promise frame that actually goes on some request potentially. We've been talking about the whole terminate to reverse proxy use case where you'd potentially send a connect request and in response, maybe not directly, but we would essentially inform, or like in this case, the proxy would inform the connect requester that a certificate is essentially incoming and, use me directly. And so it turns out that, modeling very similarly to server push with like a server certificate promise, telling that request that this stream ID is about to be opened to send a certificate could possibly be useful. It also might be totally unnecessary complexity. So, if anyone has any thoughts there of like, is this a useful thing? Is this a waste of time? Um, you know, this is, of course, the forum to make that known. Um, as an alternative, we have a.
Yeah, sorry,
Alessandro in the
Alessandro
queue.
Ghedini, Cloudflare. It seems like it could potentially be a problem, but it also feels like something we could fix when we have that problem rather than now.
Yeah, right. There could be an expansion here that it's not obvious it's useful right now.
Mike Bishop, no hats. I'll also observe that this type of promise has a nice property in that if you don't care, you ignore the frame and you move on with your life. Also, I don't think there's any requirement to send it for the certificate to work. So it's nice that it's entirely optional on both sides. Reserve a frame type, throw it in there, and people can experiment.
Yaroslav.
Yaroslav Rosomach, Zscaler. From my perspective, there are many potential use cases for secondary server certificates. It feels that it's best to keep this work concise and then perhaps introduce extensions that would deal with reasons why one would ask for certificate or push certificate. So I'm not sure about having promise in this work.
Lucas Pardue, Cloudflare. This reminds me of some of the stuff we talked about a little while ago. Like, I don't want multiple frames in H2. Like, there's a solution to this problem, use H3. No, like, we're thinking about other ways that you can maybe do that. If this becomes a real bad problem for the H2 deployments, then we'll maybe do a new thing for that. And to Mike's point, like, we really need to think about the impact to the intermediaries and everyone else if they were to do this extension. It makes it a lot harder to use, in my opinion. So, yeah, vote for close without any action.
All right, that drains the queue. Do you want to jump onto your next slide?
Yep. Well, and, just adding to this, if we were not interested in server certificate promise, but we still wanted like a new stream type, that is also another alternative in line with this solution. That said, my final slide here is yet another alternative, which is that we could just give up on trying to support this for H2 and say, haha, HTTP3 over QMux. Obviously, this is not necessarily meant to turn into a QMux discussion, but I did want to highlight that this, of course, is a real place where, by having to support some of the existing limitations of H2 and sort of do double work for any extension, if this ends up being one example of a place where, considering, HTTP3 over QMux or whatever is a useful thing to kind of like, okay, then we can just iterate on extending H3 primarily. Potentially that helps us sidestep this whole issue. So I thought I would raise that briefly to attention. So I guess as far as like next steps actually go here, There is kind of the question of, do we actually like really want to put all this effort into solving this set of problems, all for H2, or um, do we still want to continue to go down the new stream type route, or kind of revert back to the older, just, a new frame type is sufficient? Guess that's kind of the set of problems we're working in as far as the main issue for this draft is concerned right now.
Okay. Yeah, that's a good question. Martin Thompson, go ahead.
Yeah, so I don't think this is the answer. I think Lucas suggested that you accept the limitations of what's present in HTTP2. I think that's probably okay in this case, particularly since you can increase the size of frames in HTTP2 if you're really crazy. And I think some people, I'm not aware of anyone that does, but the option exists if you want to send large, or you want to accept large certificates. And then the size limit is considerably larger and probably won't be a problem. But at least until we have those crazy post-quantum certificates, we'll probably be okay. I say that with some reservations, of course. So I would say I was a fan of the idea of a stream, and then I looked at the state machine again since, and I think you would probably need something like a push promise in order to have a server sent stream without committing major violence to the state machines, and this feature doesn't really justify that. Whereas I think in HTTP3, a new unidirectional stream type is very easy to do, and is the only sensible solution there.
Okay, thank you. So I got in queue more speaking kind of like as chair here from the process standpoint. I guess one aspect, Martin, to what you're saying is like there's going to be other discussion around post-quantum certificates and do we have Merkle trees? Like that's a whole world that's going to evolve. I don't think we want to pre-predict too much of it. We can always come back. We also, the chairs got a request for looking at some other secondary certs on the other side, which is something that we had originally declared kind of out of scope for this. But there's interest in still grappling with this area. So we do have an option to say like, great, we have a simple thing here. Let's do the simple thing, ship the simple thing, but then come back and like keep working on other iterations of this area. So that could lead us to a solution where we say, let's try to keep things simple rather than boiling the ocean so that we have something that does work, acknowledge the limitations. But since we have cases where this is viable in many scenarios, maybe that's something that is okay. And looking at the open issues on this document, it kind of seems like we have two cases of things that we could do, but we're not sure we want to do. And we don't seem to have a lot of people shouting that we really have the energy to do it. So potentially we can move on without those and just try to finish this up. And then I think we do have energy to keep looking at other aspects here. What do you think, Mark?
Yeah, I think I agree with that. The only thing that I'd add to that is, with all of that said, it certainly is food for thought for the discussion of the long-term evolution and things like QMUX, and in that we have limited resource, we have limited attention of everyone in the room, and being intentional about how we use that is an important thing. And without opening that whole box again, there are arguments on both sides of that. So we need to have some careful thought and consideration in the community about how we use our resources.
Okay, I don't see anyone else in queue. So I guess I would ask maybe authors kind of relook at these issues, see if you say we want to close them out, maybe take another pass over the document, see if you think it's in the right shape, and then maybe we can look at progressing it. Maybe we send something to the list about that. Yeah. Thank you.
Yes, thank you. So next up, I think we have to connect TCP. We do.
Ben,
Okay.
do you want to share from your end? You can be the driver.
Sure.
Granting. Ta-da.
Okay, let's talk about Connect TCP. This is the same intro slide as usual. Note that in the previous revision of this draft, we declared that the capsule protocol is in use. Connect TCP means you are using the capsule protocol. So there is a capsule protocol header that you should send. You can do this in HTTP 1.1 or 2 or 3. The big changes since the last time we talked about this draft are mostly about connection closure. There's some other stuff about resource exhaustion attacks, which is actually connected to that. A lot of those attacks are about what happens to connections after they close or as they close. There's also some new advice to just please don't use HTTP 1.1 if you can avoid it. I got a lot of sharp edges here. And I'm going to go through each of those topics. So first, the new connection closure rules. I'm not sure that it's really worth walking through the full details of the state machine here, but I will briefly give you an overview. In the previous draft, we said normal TCP data goes in a capsule, which is called data. Somebody asked a couple days ago if that represented a TCP segment. It's not specifically what TCP calls a segment. That is a block of data that fits in a single IP packet. There's no connection here to IP packets. Each capsule is just the next chunk of TCP stream data, and that chunk could be any size. The new addition here is that there's another capsule type called final data. So in TCP, the last segment, the last TCP packet of a data stream can have a flag on it called fin, which means end of stream. So in Connect TCP, that's now represented using a final data capsule, which just like data can carry payload. It can also be empty if the stream closes without any further payload. So if you, as an endpoint of this protocol, if you see your TCP connection close cleanly, then, so if you see a fin flag, then you have to send a final data capsule, empty or not. And once that's done, you can't send any more data or final data capsules. You're done sending TCP data. If your TCP connection closes, which is not the same as receiving a fin, then you should gracefully close your send stream. If you get a TCP reset, then you should abruptly close your send stream. I misspoke slightly. Some of these requirements are musts. The ones that are shoulds, I've highlighted here. One of the reasons we marked should close send stream abruptly as a should is that it seems like there are some situations where it is difficult to close a send stream abruptly, especially in HTTP 1.1. So while we think that's a best practice, that's what we really want people to do, there are some situations where it's difficult to do that. And similarly, if you see that the received stream, the incoming stream to you, is closed abruptly or is closed cleanly but without the final data, then that is equivalent to a TCP reset. You should emit a TCP reset on your side of the connection. Or if you're an integrated client where there isn't really a TCP connection, then you should signal a truncation event. So the results of this is that at must level, if everybody complies with the must level requirements, then a final data capsule proves to you that the incoming data has not been truncated. And if everybody complies with the should level requirements, then a graceful stream close means that all of your outgoing data has been delivered all the way to the final TCP server. So this is hopefully a relatively simple state machine that gives us a lot of nice properties. We went through a large number of iterations, and there was a bunch of feedback from lots of people, including the ones named on this slide. So thank you, everybody, for working through this interesting problem. So here's a quick diagram of, I want to show off the cool ASCII art diagrams that the draft now contains. We can come back to this if anybody wants to talk about it.
It's very nice art. Good job.
Thank you. So there's some text now about resource exhaustion attacks, which is something that came up in the context of connection closure, and specifically in regard to the TCP time wait state, because TCP creates some situations where a connection can be closed, but still using resources for several minutes after it is closed. And that resource usage is asymmetric, where only one of the peers ends up holding onto that state and essentially locking up a 5-tuple, a pair of client and server ports for several minutes. So that creates some potential resource exhaustion attacks. If you don't, ultimately, I think this is basically pretty standard anti-abuse stuff that any proxy or really any service operation has to deal with if it has untrusted clients. But it didn't seem like a bad thing to go through some of the maybe less obvious misbehaviors that a client could abuse and talk about some of these suggestions for limiting things like the maximum receive window, because otherwise a really tricky TCP peer could potentially force you to buffer gigabytes of data in memory without actually having to buffer anything on their end. So we can talk about, if anybody wants to adjust that text, that's, we can certainly do that. And finally, there's now some recommendations to avoid HTTP 1.1. And again, I don't think this language isn't terribly strong. I don't think this should be controversial. So I have prepared an implementation of this draft in a branch of the mask.go implementation of Connect UDP. And hopefully we'll get to do some interop testing soon. But for now, I'm not aware of any other implementations. One thing that I did discover in the course of that implementation is that as we knew, like sending TLS alerts can be difficult in a lot of TLS libraries. So signaling an abrupt stream closure securely in HTTP 1.1 was a challenge. One thing that you can do, it turns out, pretty easily is to kill the TCP connection in such a way that the finished message is never sent. And arguably that's just as good, although it's a little less explicit. So I think there's a question about whether we should adjust the recommendation in the draft. Yaroslav, do you have thoughts?
Yeah, that's actually exactly what I was going to ask about. Right now, there are quite different paths for HTTP 3, HTTP 2, and HTTP 1.1 over TLS and HTTP 1. Here, how do you generate RST, which feels like implementation nightmare, but in many cases, want to be transferred to TCP RST. So we don't just do a capsule for RST if you really want to signal it through, or maybe a flag and final data that would tell if it's FIN or RST. That seems to be more universal solution without having to dive into specific APIs of specific HTTP and all their limitations.
Sure. So I'm happy to talk about that. What the specification says to go back to the state machine, is that if you receive a TCP reset, you should close the send stream abruptly. And maybe I should add that you must close the send stream. I think closing the send stream can fairly be described as a version-independent action. If the send stream is closed without sending the final data capsule, then on the receive side, you will emit a TCP reset. That's the next bullet. So effectively, yes, the specified state machine is transparent to TCP reset, even without any version-specific behavior. The only thing, if you want to call it version-specific behavior, is about abruptly closing the send stream. And what that allows you to do is to signal reset after fin. So imagine that you've already sent final data. Your send stream is closed. Then you get a reset on the TCP connection, which is only half closed at that point. We'd like to still be transparent to reset in that situation. And that's the point at which we rely on abrupt stream closure, which does exist in every version of HTTP, but it's different version by version.
Okay, so if I understood correctly, and let me rephrase it, you always expect it to end with final data capsule before closing the stream, regardless of the version, and that's the indication of fin. If you don't do it, then you're supposed to generate RST, and the rest of RST generation mechanisms, it's more of a description what you are supposed to do when something unexpected happens, like TLS alert. Would that be a fair statement?
So specifically, there are situations that I have learned about through this process in TCP where you can be talking to a server, for example, the server finishes sending data to you. You attempt to send more data to that server, and that server sends you a reset, which means I rejected the upstream data that you were sending. So before the fin, the mandatory requirements here, which are version independent, are sufficient to be transparent to resets. After the fin, we have to work a little harder to be transparent to resets because we need abrupt stream closure, which is not that hard, but is a little more work.
Okay, makes sense. Thank you.
Going back to the last slide that you were presenting, which was discussing if we need to say something specific about TLS alerts when being used on top of HTTP 1.1. I kind of think that we don't need to say that, considering this is a generic problem of HTTP 1.1. We've always have had it, and it's not going away, I'd say. And especially since we have this final data capsule now, we have additional protection for Connect TCP that I think it's fine for us to have these kind of defenses. And then maybe we don't need to do some kind of special casing, the Connect TCP for HTTP 1.1. I don't think we need it.
So right now, the draft recommends sending TLS alerts. It says, if you are in this situation, you should send a TLS alert. And so what I'm thinking about is maybe that we should adjust that text to say, if you're in this situation, you should close the TLS stream without finished.
Well, either ways, because we have final data, so it will work.
The impact is pretty small either way.
David Skenazy. First, just as a clarifying, I think you don't mean finished, you mean close notify for this one.
Thank you. Close notify.
Yeah, no worries. Then I think I agree. From the discussion here, what makes the protocol work and what makes the other side know whether it was a clean or an unclean closure is the final data capsule. And so I think in terms of the musts, the real normative text, we just say if it was abrupt on one end, just don't send that final data capsule, because that's how you say that it was clean. And then maybe we can list here are some examples of way you can explode this thing. And it could be a TLS alert, it could be killing it without close notify. But I think the must is very small, and then having a list of things like here's how you can do it is probably best because, like you discovered, different implementations have access to different tools for this thing.
Yeah, so right now we are a little more prescriptive than that. The text says you should close abruptly, and it lists in H3, use this error code, in H2, use this error code. In HTTP 1.1 for TLS, for not TLS.
So I think I'm agreeing with you in that the current text is too prescriptive. We just need to make sure the bare minimum for interop is there, which is final data, and then be less prescriptive in the ways that you tear things down.
Okay, I think I want to get clear on what, right now, for example, the text says that if in HTTP 3, for an abrupt stream closure, you should use I think it's H3 connect error code, right? Reflecting that this is an error related to HTTP connect. Like, we could remove that recommendation, but I think it seems like a fine recommendation to me.
Okay, and then I'll let this go. I think having a key difference between the must on this is how you define clean closure and don't send it unless it was clean. And then for the other ones, this maps the HTTP mindset of, you must close this with an error code, and then you should use 421 because why not? But anyway, okay. I think we can jigger a text
I think that's
accomplishes that.
Close enough to the status quo, except for HTTP 1.1.
Okay, then, yeah, great, sounds good.
Okay, I jumped in queue briefly, kind of to respond, Yaroslav, to your suggestion. I think the details we worked out, but just like with regards to the reset, I think part of the logic also is when you have the proxies, like the proxy connection itself, close abruptly, you have to do something, and you should send a reset then because something went bad, and so it's not clean. And so I think because we have to handle that case anyway, and because that leads to a reset, we shouldn't have extra reset capsules unless they transmitted more information, because then we just have two ways to say the same thing. So just a little comment.
Yeah, I agree with Tommy there. This discovery, I probably should have noticed this when I was going through the review of it. I'm not aware of very many TLS stacks that will give you the same ability to send an alert of your choosing, or even a close notify. And close notify is a problem because close notify is a clean termination, and that's not what we're looking for in this case.
Right.
So close notify is really the only one that most TLS APIs will give you access to. So I think the only change that you need to make there is just say, look, you got to reset here, propagate the reset there, and that will do the job.
So I guess, sorry, to Martin's point, the text says to propagate a reset for insecure HTTP 1.1. For secure HTTP 1.1, to be precise, it recommends closing the TLS connection with some kind of error, but closing the underlying TCP connection cleanly. Because otherwise you are using an insecure insecure and unencrypted signal to try to convey something about the interior content.
Yeah, I think perhaps you're trying a little too hard there. There's no way that the TLS connection is going to be able to continue after the TCP reset. So it's not like you're any better off for having the TLS level alert. It's not one of those situations where suddenly magically you'll be able to distinguish between these things. This is a failing that TLS actually has in it, was this idea of the close notify, and the idea that you could have a reliable close arrangement at the TLS layer that was authenticated. In practice, that just doesn't happen. And people close connections all over the place, and you never see a close notify in a lot of cases. And the world just moves on. And yes, that means that HTTP 1.1 has all of these wonderful truncation attacks, but that's what HTTP 1.1 is good for. All the wonderful attacks that, the smuggling things and the whatever else. So I would say you've chosen a bit of a dud, and you're going to get dud security, right?
Well, okay. Thank you. I will prepare a PR here. I didn't hear perfect consensus on, but I heard a pretty good consensus on what direction we're going. Okay. I think this is ready for working group last call. But we, we'll make that change and we'll see how people are feeling.
Okay. So it sounds like we'll see one more revision and then you can email out and ask for a last call. Sounds good. David.
On the topic of last call, David Skenazy. So I know I've said there's 2 IETFs in a row, so now I've brought shame onto my whole family, but I do want to implement this. And I think we should, I don't think that should block working on this last call. We had a whole discussion around that in web transport, but I think we should have at least 2 implementations of this before this goes to the ISG. Sure. And so I'm not going to say it has to be my implementation because God knows when I'll be able to do it. I've been 6 months late already, but at least having someone from the community just to make sure that this works, because a lot of these details, like Ben picked a specific stack using Go that found some interesting TLS things, we're going to learn from implementation. So I want to totally happy to do work group last call. I commit to reviewing the documents and sending feedback, but I hope we get some implementation from either, I'll do it if I can, or from anyone else on top of Ben's implementation with Interop before we send it to the ISG. That would be great.
Ben, would you or someone with your implementation be able to help do some hackathoning next time, or arrange some other interop tests otherwise? I'd also be interested.
Well, I can't promise that, but it's a good idea.
Yeah. I mean, at the very least, I think maybe even if you're not able to, we should try to arrange some hackathon interop next time. That's always a good idea. I think we can still, double check the text as a working group in parallel. Okay. Thank you. Kazuha, are you presenting or is Ben presenting? Ben, okay. Ben, you're just going to keep talking.
All right. Okay. So these presentations are all very much related. All right, version translation of the capsule protocol with me and Kazuha. So we have these 2 different things. We have HTTP 1.1 upgrade, and we have in H2 and H3, we have extended connect. They both, so here's an example of what a connect IP request looks like in each of these versions. Notably, both of them pull from the same upgrade token registry. And in this example, they both create a connect IP tunnel, which then speaks the identical connect IP capsule-based protocol on both sides. So these 2 requests are interconvertible. Intermediaries are free to take one of these requests and convert it into the other one. And that's actually pretty important because it's very common to have a different HTTP version on the client to reverse proxy leg in a large implementation from the HTTP version that's in play from a reverse proxy to a backend. Okay, but what if it wasn't connect IP? What if it's upgrade token bar, some like unrecognized upgrade token that was, I guess, defined after your reverse proxy code was updated? Can you convert between these 2 requests? The answer is no. You cannot convert between these 2 requests because you don't recognize bar. This was surprising to me when I started to understand this. And there are a couple of reasons for this. I think the 2 core reasons are that some of the existing upgrade tokens really don't behave this way at all. They preserve the method. The method is actually meaningful there. And so the correct conversion from HTTP 1.1 to HTTP 2 would actually be a get method, not a connect method. None of these upgrade tokens are in use, at least widely on web-like uses of HTTP, it turns out that maybe the TLS upgrade token actually is in use in the internet printing protocol. That's one category of reasons why this can't be done in general. And the more general reason why you can't do this is that we just haven't promised any restrictions on how future upgrade tokens might behave. They could do anything. So we, just because the existing upgrade tokens are all or arguably all the same across HTTP versions, it doesn't necessarily mean that will be true forever. Okay, but let's go back to that bar example. What if that bar example said, I'm speaking the capsule protocol? Now we have a pretty serious restriction on how this protocol behaves. It seems like, you know, this is sort of an unrecognized protocol, but it's a subset of the capsule protocol, right? It's a series of items taken from a particular registry. It seems like maybe now we could actually do that kind of conversion. No, we still actually can't. The reason, again, is because we haven't promised any restrictions on how future upgrade tokens might behave. They could do all sorts of strange things. And the capsule protocol hasn't actually promised any restrictions either, except that if you see a datagram capsule, that can always be converted to a datagram frame. In my view, this is annoying. And Connect TCP is my example of why this is annoying. So let's say we finish Connect TCP and we get it out into the world. And I say, I would like to use Connect TCP through a reverse proxy that already is aware of Connect UDP, for example. Connect TCP, any Connect UDP proxy is completely ready to forward Connect TCP. But because the upgrade token is unrecognized, I can't use it through this reverse proxy. It won't forward correctly if there's at least if there's a version mismatch. And probably because of that reason, the reverse proxy will just be configured to reject unrecognized upgrade tokens entirely. Even though I'm not asking the intermediary to do anything. It literally just needs to be added to a list of supported tokens. And I think this creates friction for generating new capsule protocol upgrade tokens. And it creates a strong temptation to just tunnel stuff through something else that is already supported end-to-end, basically bump up a layer in the stack so that you can get through intermediaries. So can we fix this? Yes, I think we can totally fix this. The proposal in this draft is to just declare that capsule protocol requests can be translated freely across HTTP versions in the very obvious way that I was showed on the first slides. This has a bunch of implications. What it does is bind us as the standards community, because it means that for all future upgrade tokens, we have to obey a bunch of restrictions, like you can only use GET in HTTP 1. Use connect in HTTP2. There are a bunch of other subtler restrictions. So that's what's proposed in this draft. And I think that's really a very minimal cost to us to make life easier for a bunch of implementations and reduce friction in that implementation path. But there are some interesting questions. Maybe the number one question is, what about web transport? Because web transport actually is an example of a upgrade token that exists on these 8 different HTTP versions, but actually is not at all trivially convertible across them. So today, to make this work, we would actually need an exemption that says like, all capsule protocol upgrade tokens are version convertible, but if you negotiate this HTTP extension, then actually it's not. And by the way, I filed an issue on the web transport GitHub issue tracker to see if I can convince them to just use different upgrade tokens for the thing that goes over HTTP 1.1 and the thing that goes over HTTP 2, since they're pretty clearly not the same protocol. And the other thing to say here is that you actually don't have to just key this off of the capsule protocol. We could define something like a parameter for the capsule protocol that says it's convertible, or like a totally new header that says, actually, never mind capsule protocol. This is a version independent upgrade token. So you don't need to understand it to pass it along. Okay, that's the end of my slides.
Cool. People have thoughts. Thanks, Betty. Mike, go ahead.
Okay, so Mike Bishop, no halves. First off, the Web Transport Working Group.
Close to the mic.
Sorry. It's a little short. All right. All right. So the Web Transport Working Group discussed whether they wanted to make the foray into defining web transport over H1. And there was not much interest in the room in actually writing that down, even though it's a fairly small step. So at least right now, this just doesn't exist.
That's sorry, I don't think that's true because this I may have said HTTP 1.1 in error. I'm talking about version conversion of web transport between HTTP 2 and HTTP 3.
2 and 3. Okay.
Which are also quite different protocols as specified and are not trivially convertible.
That, yes, I think that is probably true. I'd have to think more about how they pass their settings. I'll also note that the behavior you talked about responding to the HTTP request, if you look in 9110 and the definition of upgrade, the capabilities and nature of the application level communication after the protocol change is entirely dependent upon the new protocols chosen. However, immediately after sending the 101 switching protocols response, the server is expected to continue responding to the original request as if it had received its equivalent within the new protocol. So technically, even though we've defined a lot of them now, it's the ones that don't reply to the request in the new protocol that are the exceptions.
Yeah, we've definitely started using upgrade in interesting new ways.
Yes. So as to exactly how we lock this down, or if we lock this down, I don't know. I'm inclined to say that you shouldn't send a 101 for a protocol you don't understand.
So I think what I'm arguing here is if you're an intermediary, you wouldn't send a 101 right away. You would forward the request upstream. And if you got a 101 back, you would forward that back.
Or 200 over connect. Yeah.
Yeah.
So I think probably saying that you can mostly do that for capsule protocol is probably okay. I'm not convinced that you can do that in general.
I agree. You certainly can't do it in general. The question to me is, can we and how can we identify when that is true to make life easier for intermediaries?
Mark, speaking just for myself, I hope it won't come as a surprise to most folks in the room, but I generally don't focus very much on capsule protocol. When I don't always want to tunnel through HTTP, but when I do, I use post. But just from a general protocol design perspective here, as I understand it, capsule protocol is this kind of escape hatch for lots of new things, and putting arbitrary constraints that might, cause friction in the future, maybe not arbitrary, but a bunch of constraints on it, seems a little risky. Which your convertible spelling here, so positively flagging it that you effectively conform to a profile, seems to me like a much more sound approach from just a general protocol design standpoint, if I understand what's happening here.
Yaroslav, one statement that, if I understood correctly, was made previously about datagrams, that you could potentially convert between datagram capsules and H3 datagrams. There are obviously a number of interesting sharp edges there in terms of MTU. So MTU capsule can potentially be of any arbitrary size, and datagrams and HTTP3 are very limited. And also behavior of application could be very different depending on if it assumes that datagrams that it does are lossy versus they are lossless. So it could use potentially different codecs or apply different logic just based on that. So I'm not saying it cannot be converted, but there are a number of sharp edges to consider.
David Skenazy, longtime capsule enthusiast. This reminds me of conversations we had in the datagram design team in Mask back in 2021. And Ben, you were there, a bunch of others in this room. And at the time, I was very strongly convinced that we should make the capsule protocol header mandatory, specifically to allow these kinds of translations. And not that that meeting was confidential in any way, but Ecker was strongly in the belief that we shouldn't make it mandatory, so ended up with a may and a should in the specs, and it wasn't mandatory. It's one of those cases where I have to begrudgingly admit that he was right and I was wrong, precisely because of how hard this turned out to be. At the time, it was like, oh yeah, the capsule protocol, you'll be able to swap between them. That sounds like a really cool feature to have, and it'll just work. And the web transport between H2 and H3 has demonstrated how getting that to just work is not going to be easy in any way. So all that to say, I conceptually like this idea. I like the concept of being able to write intermediaries that can transparently go from one to the other. In practice, this has ended up being way less simple than I thought. So I think you could make it work. I think your design here with a convertible, I like that name, we can have some fancy race car logos, is really good. Like defining a profile of the capsule protocol where all you use is the capsule protocol and maybe datagrams, like what was in 9297, then if you say, I limit myself to this, only translate that, everything works, you can make that work. I totally believe that. The question becomes, what's the point? And it becomes down to everyone in the room's ability to predict the future, which we all suck at. If we think that there's going to be an explosion of these LPNs that have this, then yeah, it makes sense to build middle boxes that can upgrade or translate between those two versions of this profile. My intuition, again, it's purely intuition, none of us can predict the future, is I don't see that happening. I think all of these things that we've thought of, we've brought here, and half of them don't match the profile. So I don't know how much we want to do this. I totally agree that this should work. It sounds like a good idea, but I kind of want to wait for, like, do we actually have a problem that we need to solve? Because right now, the people that would implement this are already following what's going on in the HTTP, the Mask, the potato working groups, and they know what's going on and they'll just list those. So that's kind of why I'm on the fence here. I'm not strongly opposed at all, but I don't think we've quite hit the mass of there's really a need for this.
Sure. So in terms of things that fit and don't fit, I'll just say connect IP, connect TCP, connect UDP, and connect Ethernet. Are all examples of things that fit this. And I'm not 100% sure that if I went to every CDN vendor in the world, that they would have updated their implementation to account for Connect Ethernet, for example. Web transport is the odd one out. I actually do think that, like I said, by splitting the upgrade token to acknowledge that these are actually distinct protocols, we could fix that too.
Sorry, Kazuho, can I respond as a closer? Yes, so this is a real problem for us because in my case, I'm just working as a proxy. And for each new upgrade token being defined, I have to modify my source code to explicitly pass through that new thing, even if it's as simple as connect TCP or connect IP over H2, just passing through the capsule. So this is a real pain. And I wouldn't mind if this is going to be an opt-in, like version independent upgrade or something, but I really want to have a way of indicating that I can pass through this extended connect thing without changing my code.
Eric Kinnear, Apple. I had some similar thoughts in that I don't love all the spellings here, and I don't love our historical ability to predict what will come in the future. I was almost going to suggest that we make a column in the registry for these upgrade tokens that specifies something about this, but then you end up in exactly the same problem of I still have to go and update all my code every time something changes. So some
At least you don't have to read the RFC.
That is true. That does help. But so there's a little bit of what are we actually trying to solve? Can we, if we can clarify what we're trying to solve, I think this is a problem that we've had elsewhere. Web transport is a great example. I would be decidedly interested in having a standard set of building blocks that we could say, great, this is how we apply this to web transport, rather than trying to go reinvent that for web transport and do it all over again in a few years. As an example, with web transport, you could imagine saying that the web transport upgrade token is the version that uses capsules and runs on any bidirectional byte stream and can be translated. And if you know how to support it, you can turn web transport into web transport-H3 that breaks things out into individual H3 streams, right? Because you don't have to do that to carry web transport over H3. You just get a stupider version of web transport. So if you do the thing and you don't think about it, then you don't think about it. And if you're actually going to deploy this in a place where you care, then maybe you do the extra work to do the special handling that's defined in the document. So I think as a general principle, saying special handling needs to be something that is defined in a document that you would read and modify your source code for, and things that don't require special handling is kind of the opt into this thing and kind of the default for what you get if you do that. That seems like a nice principle. This spelling makes me a little nervous. Some of the constraints that you had on one of the slides feels a little bit, yeah, this list feels a little iffy, but I would be generally interested in putting time and energy into solving this kind of problem, because I think we keep running into it and we need something that's a little bit better.
Yeah, we'll see.
Hey, Lucas Pardew. I don't know what to do here. But I wanted to and I joined and left the queue and joined again. Like, I don't have this problem quite yet. The Cloudflare Edge supports get and upgrade, and we do kind of what Ben was saying at the start. We will pass that through to the origin, and it can do a 101 and come back. And the protocols that they're upgrading to, we don't know what they are. We don't care, right? Yeah? People want to pass through stuff and they want to do their own thing. They're allowed to, right? It's a byte stream and we pass it through. So the problem kind of doesn't exist until you do extended connect, and then it's going to be a world of pain with these things. So I think that there's a problem down the line that could happen, but I don't know what the shape of the solution would be. And it's not helpful, I know, but it's an opinion.
Thank you. I got in queue next, and just as a note, I think we're going to wind down the queue on this one. Thank you, Kazuho and Lucas. One of the things I wanted to ask was, like, to what degree do we feel the pain here, and like how often is this happening? I know, like, it may be different for some web transport cases where we expect a lot of translation. I think there are a number of the modern connect proxy style things that may or may not be going through any intermediate translation, like particularly for the H1 to H2 or H3 cases. I wonder how often practically we're actually translating a lot of those. I know a lot of them might be pretty surprised if we're having particularly any clients reaching out initially with H1. So I think getting a sense of that usage for some of these will be important.
Eric Nagar-Nakamai. I think this is definitely a problem we're solving and spending some time on. I think there's enough cases where you, like in the CDN world at least, you have the client that wants to talk to the CDN, and the CDN may have multiple intermediate hops where it goes H3 comes in and it does H1 internally, and then it does H2 to origin. and where the origin wants to be able to talk one of these things with capsule protocol, and when you want to kind of be able to pass stuff cleanly through this, that having that well specified, so it's not just the pass-through upgrade and a byte stream and hope would be worthwhile, especially so we can like add more of these in without an intermediary like a CDN needing to have to kind of, worry as much about the code changes needed for each one to handle that case of be able to pass a byte stream through to the origin.
Eric Kinnear, sorry to join the queue twice to make things more complicated and not less. The other thing that tends to become an issue here is the presence or not presence of settings in H1. That tends to tie a lot into places that we use Extended Connect. So while I am quite interested in something that makes this easier, it would be good to do a lot of thinking about exactly what we're actually trying to solve and what we care about.
Because also regarding Lucas' point, I understand that the proxy is being designed in the HTTP 1.1 era didn't care about what the version, if the upgrade token is version dependent or not, because there's only 1.1 and they just pass through everything. So we are currently in a murky situation because we created multiple versions of HTTP that we have this ambiguity. So I think we have to do something to clarify at least. And if we are going to spend some energy, I think we want to have a way of indicating if it's version agnostic or not, because it will be helpful. So I prefer going that direction.
David Skenazy. So it's sounding like there's energy to do this. Kind of somewhat orthogonally, Lucas and I have been discussing doing a BIS of 9297, which is the capsule protocol document, because I think the large deployment over the public internet these days has shown us that the capsule protocol works, but we've also found a few bugs here and there with it. Like one example is that any error involved in the capsule protocol is emitted as a datagram error, which is just not quite right. Another issue that we found is that there's no way to like datagram frames in quick, and therefore HTTP datagrams in H3 have a limited length from the MTU, but the ones in capsules are infinite, where folks in the web transport space were saying maybe we should have a way to say don't bother sending anything bigger than X because we'll drop them. So anyway, we're looking at maybe reopening that can of worms. I'm wondering if maybe we join forces on this as a capsule protocol V2 that solves a lot of these issues.
Let's put that to the side just for the moment, because that may complicate our understanding of this issue, but that's good to know in the background. Thank you. So just to gather maybe just a little bit of information at a coarse granularity, we'll just do a poll. Should we consider working this area? We being the HTTP working group, of course. Just get a sense of the level of interest in the room, and also if there's people who firmly believe we shouldn't be going down this road. So I'll start the poll now. It is yes, no, and no opinion. You can also use no opinion for I don't have enough information, I think. It is a Mitico. Mitico. I'll get it right. Yeah, everyone knew that. Mitico. Okay, so we're seeing kind of a split between the yeses, which we've certainly heard the mic lines of interest in this area, but also a fair amount of uncertainty, either no opinion or I need to know more before I can have an opinion. We had one no and they've disappeared. Don't do that if it's just, you feel alone. You might have the reason that we all need to hear. So. Okay, we'll close in just another few seconds. If you haven't voted, please do so. Okay. Oh, the no came back. Oh, and it went. Someone's messing with us. It's Friday afternoon. I get it. Yeah. Skenazy, I need to see your hands right now. Okay, cool. All right, we're going to close this. Good. All right. Thank you. So that's I think, interesting information. It sounds like maybe we need some more discussion as a community before we can confidently embark on this. Did you want to add anything, Kazuho?
Yeah, sorry, I was just wondering if the no opinion people included don't care either ways, like then it could be interpreted that if there's interest in the folks among who care.
Yeah.
So maybe
Some may have, yes. The people who generally don't care are probably doing something else right now. But yeah, that's a point. So I think we'll continue the discussion. If folks feel that they have some opinions or perspectives that'll help the authors kind of make progress and evolve their proposals, they've obviously heard some here today. Please give that to them either on the mailing list or privately. And I think we'd look forward to continuing the discussion on the mailing list and hopefully hearing from you again in another meeting. Is there anything else to add? That's good. That's good. Okay. All right. Thank you. Thank you both.
Next up, we'll have someone who we haven't heard from in a little while. I think Ben Schwartz will give us.
Is he with us?
The slides even look similar.
Oh, you're muted, Ben.
Okay. Last one, I promise.
Oh no, we promise.
So HTTP request proxying is this like really old thing. I remember being on campus networks and being told that you should use this request proxy, which is a box in the IT office, because it has a cache and it won't use up your network quota if you download cached stuff. And so you would configure your clients to use some specified forward proxy, and it would reduce the amount of load on the shared network link. Those days are long gone, but HTTP request proxies are still around. I can tell you in my recent experience that they're heavily used. They mostly seem to be used, as far as I can tell, in very infrastructure or enterprise contexts, situations where you want to make an HTTP request, but you can't do it yourself, maybe because the source of the request doesn't have direct access to the internet, or there's some policy enforcement that has to happen to check your request to see if you're complying with all sorts of different kinds of requirements. In a sense, HTTP request proxies can be thought of as an API for requesting HTTP requests. In HTTP 1.1, there was a special syntax for forward proxy requests, where you dump the entire URI in absolute form into the request line. Notably, there's a host header, but the host header specifies the origin of specifies the host that's in that absolute URI. And in HTTP 2 and later, there's no special request form. You use the same pseudo headers. You just take the request that you would have sent to somebody else and send it to the proxy instead. So this form is really old and it has a bunch of limitations. There's nothing in the request that indicates a host name, so you can't virtual host forward proxies. Every distinct forward proxy needs a unique server IP address. And so that's bad for privacy. Like, we're now revealing more information in the IP headers than we needed to. It's bad for cost if you need IPv4 addresses. It's just operationally annoying if you're used to managing normal HTTP services. One level deeper than that, there's no path separation. There's no ability to do URL parameters. So you can't convey any information. There's basically nowhere to put any additional information that you want to communicate with the proxy. And I said that every proxy needs a unique server IP address. You might think, oh, well, I can at least use different ports on the same IP address. And you can, but because the port number isn't authenticated anywhere, an attacker, if you're worried about such things, can actually move your connections between different ports, and you don't have any way to know. So these are some of the reasons why I think this is a problematic arrangement, although it has worked for 30 years. So we have templated proxies for UDP, for IP, for TCP soon. What about for HTTP? So this is what the draft proposes. It says we specify a forward proxy template, which is very simple. It just has a parameter for the target URI. And then we expand that template. And other than that, we do everything exactly the same way as current forward proxies work. So notably, the method is whatever your method was, and the content type, and et cetera, et cetera. And the proxy prefixed headers apply in the usual way. It's just changing the way the target URI is presented. So one puzzle that you get into here is if you try to support legacy configuration methods. So like, what if the client and the server can both do this new thing, but the configuration is legacy? And this is something that's supported in Connect UDP and Connect TCP, where if you're bootstrapping from a legacy style proxy configuration, then there's a .well-known template that you can use to generate your requests. Those specifications all assume that you could probe that template. So you just try to use it and see if it works or fails. That actually is very difficult in this case because a 404 could be a success response. That could be the response from the target that passed through the proxy. So we need something else. And the draft has a particular proposal here involving a proxy status parameter called use template that would basically tell you go use the default template, or even maybe go use this specific template, creating a sort of redirect capability. But that's secondary. That's stacking ideas on top of the main question. So the reason I'm here talking about this, I should say again, after 4 years, I think, because this is an old idea that I've heard here a long time ago, is that this specific proposal is now implemented in a system called G3 proxy maintained by ByteDance. So it turns out there is some real interest in this topic, and there's even now an implementation. But I think the real question for the group is, do we want to revisit forward proxying? And if so, what shape do we want that to take? Because this is one particular way, and it's maybe the most conservative way to move to templated proxying, but you could imagine all kinds of much more ambitious changes that would work. One interesting thing about this design, though, is that it happens, I believe, to be compatible with oblivious HTTP as specified. So you could actually use one of these forward proxies as a drop-in oblivious HTTP relay. Although you should probably talk to the operator about their logging policy before you do. Okay, that's the end of my slides.
Yaroslav.
Ben, if we could go back to slide 2, I think there is a small but crucial mistake here. So I work for a company that does enterprise proxies, among many other things. And this legacy construct where you do method and then you specify the full FQDN with authority, it, as far as I'm aware, works only for HTTP, not for HTTPS. You're not supposed to do that for HTTPS. For HTTPS, you're supposed to do connect, and that's the way I believe all user agents that I'm aware of works, and that's how proxies that I'm aware of work. So, which means that on the wild internet, this pretty much went extinct because everyone is doing HTTPS now. And things were working okay with connect method, at least for this scenario. I'm not saying that there are no other scenarios where you want to do some special interesting routing within sophisticated internal infrastructure where this might be useful. But when it comes to enterprise connectivity and proxies and, well, caching is pretty much dead these days in these environments, I'm not sure if that's the correct problem that requires solution. And that potentially opens up a number of other issues. If you want to signal some headers to your proxy, but not to the end server, if proxy wants to signal some headers back to you, and you need to clearly know that these headers are coming from proxy and not from end server, there are some challenges here which don't appear in Connect because you clearly know which part of request is going where and what part of response is coming from where. Those are my comments.
Okay. Thank you. So yes, I agree. This proposal does not solve the meta communication channel with the proxy as in this spelling. I want to point out that this HTTPS URL is not a typo. And I'm aware of some extremely large scale implementations that work exactly this way and actually also do perform caching, shared caching at the proxy as well. But I agree with you that user agents largely will not do this. Correctly implemented user agents in almost every case will use HTTP Connect. But not every HTTP client is a user agent.
It's Mark as myself. I guess three things. First, I noticed you're introducing a new term of art here, which we should do deliberately. Not saying that you did anything wrong here. It's just we should be careful about naming things. Request proxies. That's the new thing here. So when we already have forward proxies in 9110.
Yeah,
second,
I'm attempting to distinguish that because I think a Connect is usually also described as a forward proxy.
Sure, fair call. Yeah. Connect is a method, a request too, though. But anyway, second, if you page forward, next, where's the So there are different styles of forward proxy implementers. Some do it in what we used to call CGI scripts or something similar to that. Others are incredibly performance sensitive. And we don't have too many forward proxy folks who participate in the working group. We used to have a lot more. But parsing out a URL, an encoded URL from a header, and then using its components to decide how to handle a request is something that I know from experience will cause some of them a lot of heartache. So we probably need to have a discussion about whether that's the right form to encode this information in the request. And third, I think probably the biggest is what Yaroslav was kind of alluding to is that there may be ecosystems out there doing these things with HTTPS over HTTP and caching and so forth. But I think as a working group, we should decide whether we want to support those use cases. Next, Lucas.
Hello, Lucas Party. So the first thing that came to mind was an earlier presentation from someone called Ben about if I'm going to do this, how do I tell the proxy what version of HTTP I want it to use to make the request to the thing I'm asking it for, and all the crap that will happen because of that?
Yeah, so I mean, I think as a general philosophy, my view is that HTTP URIs are version independent. It's not HTTPS3://. HTTP URIs and resources are version independent. And if they do vary across versions, then that is an implementation detail, a variance that is not accounted for in the standards.
Okay. I'm not fully convinced, but I can follow that argument. That's cool. Different point though. You mentioned kind of the oblivious aspect, and it just made me think of all the blind caching stuff we talked about ages ago that we decided not to do. I say no one, just the work died out, which then makes me think, why would we want to do any of this? I could see that some people kind of maybe are doing this themselves, but I don't see a need to standardize anything here personally. Like, I don't think it's a good idea to do these things. I can understand if other people do, but I don't want to waste my time on it because I can't think of a use case. But that's not to say there isn't one just for me.
Sure. One use case that was motivating to me was the idea that would motivate standardization particularly was the case of an oblivious HTTP relay that wants to support a diverse range of gateways. So if you, right now, most oblivious HTTP largely is deployed on this kind of allow list basis where you create a relay and a relay resource which is tied to a specific gateway resource, and every time you want to stand this up, you need a new private arrangement with the relay. I think you can imagine, a world where clients basically contract with a relay and say, I want you to be my oblivious HTTP relay. I trust you. And then use that for a wide range of gateway resources, in which case you would need some specification for how the gateway is identified.
Okay, thanks for elaborating. Cheers.
It's I'm just a little conscious of the time, so let's get through the queue. Jonathan.
Hey, Jonathan Lennox. Just so I'm not missing something here, this proxy is fully a man in the middle, and you're delegating all identity verification to it. Yes.
That's right. This proxy sees all your HTTP headers and everything.
And all your headers, all your body, can modify anything it wants, can connect to some entirely different host, and you wouldn't know all that stuff.
Right.
Okay. Just as long as I understand the absence of security model here.
There's no absence. It's just that the threat model is whoops. David Skenazy. Actually, that's a great segue. I totally understand that there are people out there who want a security model of whoops. And maybe there's regulation forcing them to do whoops. Or maybe the employer likes to snoop and wants whoops. That doesn't mean that we should encourage whoops. And I'm going to stop saying whoops now.
Whoops.
No. So anyway, this is a thing of the past. They were very common. Like, my team deploys widely used by Chrome proxies, and we decided even for unencrypted HTTP to use connect instead of sending the GET to the proxy and having it send it, because it turns out that then you get into questions about which headers go to the proxy and which intermediaries are hard. And so we just say, don't do that at all, do connect, and please don't muck with anything inside, even if technically they could for unencrypted HTTP. But let's leave this in the past. If some people want to stay in the past and do bad things, we can't stop them, but let's not give them better tools.
Yeah, I think it would be a bad thing to see this widely deployed outside of something like an oblivious HTTP context in a browser setting, for example.
Let's continue going through the queue. Steve?
So Steve Hill. So I've spent the last 25 years of my life building online safety systems for schools, and for that we use proxies. And 20 years ago, you could take an off-the-shelf machine and you could configure it to use a proxy, and pretty much all the traffic would go through the proxy. And that's gradually got worse and worse and worse. And these days, a huge proportion of the traffic has to be picked up through transparent proxying. So my question is, given that people are stopping building clients which are using the existing proxy mechanisms, what hope do we have that people are going to implement this new proxy system in the clients?
Yeah, so I think my answer is mostly that this is not really intended for general client use. I think as as David was pointing out, there would be, there's a good security reason why client software is cautious about disabling its encryption, essentially, and handing it over to some party. Although if that party is configured by local administrative policy, then it's not clear what the problem would be exactly.
I recently ran into a situation where we had to use multiple forward proxies, and it's internal in our infrastructure, so we could just use different addresses and ports, and that works fine for us. But it's a bit cumbersome, so if there could be a better solution, I would be advocating that. We make sure all of the traffic that leaves it is properly secure, so that's not really a concern for us, but I think such a templated solution does look appealing to me.
Mike?
Mike Bishop, no hats. So I don't really want to encourage this, but I understand that it has some use cases. I'm sympathetic to wanting to be able to virtual host it and have separately stated name for the proxy versus the target. But as other people have mentioned, you still don't achieve any separation between the headers for the proxy and the headers for the request. You don't have any separation between the headers from the proxy and the headers from the origin server. I think if you want to build this in a modern, clean way, you do OHI without encrypting.
Sorry, could you say that again? That was a bit unclear.
If you want to do this in a modern, clean way, you do HTTP without encrypting the payload.
Oh, HTTP, yeah.
And there are a few other things to be worked out, but that gives you a clear boundary of this was from the proxy, this was from the origin, and even if the proxy is lying about it, you've chosen to accept the possibility by using this method. So I'm not completely opposed to doing this work, but I don't think this is the right spelling.
All right. I just wanted to comment on some of the OHTTP bits that have come up. I want to point out that for OHTTP relays, nothing stops them from using templates. It's not defined or required, but you can use it. And as a client implementer, I always ask my relays, if I get to influence them, to please use a template for the path that has the target host and path. It's easier to read. It's easier for me to generate the right thing and know what to put there. But I want to note that OHTTP relays, these proxies, still need to allow list what gateways they talk to. And like OHTTP is very different in that it has a security model where you do have proper server authentication. It's based on a pinned public key as opposed to a normal cert, but it still has that model. So I think it is different than this. I think the part about saying there's a template is useful, but nothing stops people from doing templates today.
I'm going to lock the queue in just a second. So, Kazuho?
Tommy, I just want to react to that briefly and say the minimum thing you would need to make that truly interoperable would be to agree on the format of that template, to agree on what the variable names are, basically. Otherwise, that's still a code change for every time you wanted to choose a relay.
And Kazuhoku, I just want to say that I agree that these kind of use cases exist. We do kind of this thing because one of our clients only supports H1, and we want to send requests through H2. So our HTTPS request goes through a proxy. But I think the question is like, these use cases are and should be constrained to each organization in a very particular way. So the question is like, do we need this kind of generic mechanism for flexibility? And I'm kind of wary about the security aspects, as others pointed out. So maybe we don't need to do it here.
Okay, so from a chair perspective, my take, and obviously we haven't conferred about this yet, but my initial take is, I'm looking, down at a set of tracks, and I think I see a third rail. I think we really would need to see more, have more understanding of the use cases and also the misuse cases around this, I think, and have a discussion around that. That discussion my intuition is would consume a fair amount of resource potentially, and I'm wondering if it's worth it. So if you know we can find the motivating use cases that people feel strongly about, we can have that. But it sounds like maybe some more discussion at least is necessary. Tommy, any thoughts?
I think that makes sense. Yeah.
Okay. All right, and I see some thumbs up in the room. So I think that ends us today. So thank you all for your attention. It's been a long week. Enjoy the rest of your time in Madrid and travel safely. Thank you.
Next time.
I mean, if there's a strong